Good morning, good evening, and good afternoon, whichever is currently applicable in your time zone. I am Max, and on the request, I will help click here to create a small automatic construction system. What we will be doing is to get a simple radar in the building that will fulfill all the request within specified vicinity. So let us start with 2 by 2 M building. Let me quickly check if we have exact placement. I don't see if we have, so let's move it here. Unfortunately, I don't see any cube built, so I can't move it for now. So let's quickly create a design and then we will move it. Let's see, first things first, I'm gonna need an assembler. Do we have an assembler on hand? I don't see any. Let me quickly request them then. We're gonna need 2 of those. We will need 1 behavior controller. We will also use, as additional tool, a portable radar. Construction supply. Okay, so let's start with basics. Our radar will find construction sites that we own in vicinity. Okay, great. Now I will set up owned filter. So now whenever there is a construction site within range of the radar, we will know. Let me quickly create a simple construction site. Please ignore that construction site. It's there to see if it checks. Yes, it did check. I can abort it for now. Okay, so the easiest option to make something similar that supplies anything that is within radar's area is to simply drag and drop into the assembler. This way, if I forgot one thing. Behavior controller can have 2 options. One, it can act as signal. So signal target, and signal output. In this form, this behavior will mimic a simple signal reader. I will use it just to highlight that it is possible to request items as if it was a signal reader. So if we put it here, then after we start the behavior, you can see that it requires 2 circuit boards. However, this option is inefficient. It will basically request all things as needed. So let's fix that. Let's make it a bit more intelligent. So let's start by adding 1 more parameter. And let's swap signal target to construction site local. Let's add construction site remote and 2 more parameters. Assembler 1 and assembler 2. Now, what we want to do. First of all, let's see which of these construction sites is available. So, if the first construction site is there, present, then we will operate on that one. Let me quickly add label. So, if we have local construction site, this is our priority. I will quickly unlock it just to highlight that this is our priority. If the construction site local is not present, so our local radar doesn't see any new construction sites, let's check the same thing for the other site. If there is the other site, we can take care of production for the other site. In fact, let us create a short backup. This way, when a new construction site appears, we will not basically lose what we're working on at the time. We will take care of the next construction site once the first one is finished. Otherwise, we will simply wait additional tick. Now, it might sound weird that I've added additional waiting tick if, well, every instruction works in a single tick. That's because we will quickly remove that limitation. Once we add unlock command, all the logic will be processed as far as possible. So, if neither of these construction sites is present, let us, just to be sure, clean up all the assemblers. If there are no construction sites, we don't want to produce anything. Okay, so now we have our target, that is A. And in fact, let us check if we have A as a target. If not, let's go with all the rest. If we do have a target or a construction site, let us quickly check if our construction site, which is A, is still, in fact, under construction. If it is not under construction for any reason, we will clean it up and continue back to check other areas. So basically what we are doing here is we're checking if there are construction sites, if the previous construction site has been completed and still exists. Technically, once the construction site disappears or is completed, it should disappear. But this option here to check if it's still under construction is a failsafe. Now, what we're interested is we have a construction site, so we need to load up what it needs. So let's quickly read signal, and I'll move this read signal away. We will not focus on this part anymore for now. We've already seen that we have cleaned up everything and we have what we need. So we take A, which is our construction site, and we drop it to B. B means what we currently need for this construction site. Next step is to check how many of item that we need we have in the entire faction. So we enter what we need and we get C as amount of items that we have. Next step is basically twofold. If we don't have item that we need, which is none, we will divide basically the amount that we need by 2. Why is that? Well, we have 2 assemblers. It's not good to have one assembler make more than we need. We will make it D just to make it clear. And we will copy that value D to assembler 2. However, if we make that amount, the second assembler, assembler 1 in this case, will produce either too many or not enough. So let us simply subtract from how many we need the amount we already requested. And let's drop that amount to assembler 1. This is shown in this way to make it much clearer and less weird with values going in and out. I will show you how to optimize it just in a little bit. Okay, so we have the values, the amounts. The next step is what happens if there are units, in fact, of these items. Well, if we have, what we need to do is subtract the amount that we have from the amount that we need. And in fact, we can save it as what we really need. And finally, we compare number. Let me quickly push that down. With 0. So if B, or how many we really need, is equal to 0, well, we can basically wait. If what we really need is larger than 0, that means in entire fraction there isn't enough of this item that we need, we will simply move it all the way here. We just reduce the amount that we need in theory to the amount that we really need. And if it is smaller than 0, then it means we have on hand more items that we really need. What it means is basically we're done here. What should happen now, let me quickly close it and fulfill it. Now we have construction site. So let's drag it here as our source. And let's see what's wrong in here. It saw that we have a construction site. It went to check if it is in fact a construction site. It read what we need. It found out, calculated the amount of the item that we have in the entire fraction. It subtracted the amount we had, compared it with, and it seems we have more than enough, as it goes back here. Unfortunately, it seems that there are basically a lot of things here that you can produce at hand. So it's a bit difficult to show it in the event that we don't have enough items. However, let me quickly turn off the logistics network just to make sure we don't get supplied with resources. And let us quickly drop a different factory to show you that it will in fact find the item that we need, or should find the item that we need. Just to show you that it works, I will basically remove that one. Basically it will be 0. So while it will still count the amount of items we have, it will simply subtract 0. And as we can see, we need 4 of circuit boards, and it divided assembler 1 and assembler 2 into 2 units of 2. So if we didn't have the circuit boards, then, well, unfortunately, we would create them split. However, as you can see, it only calculated them. So let's quickly connect it. Assembler 2, assembler 1, and, and we're done. Now, if just so happens that our construction site gets deleted, we can see the behavior also gets cleaned up. The major problem with this design, as is currently, is that it has quite limited range. As you can see, it will only analyze the following area. We can, however, fix that. And yes, it should need 25 circuit boards. Let me quickly give back here the variable C, and it will check how many we actually need with the materials now. It should in fact be 0 in this case. Let me quickly, let me quickly check if everything is working correctly. Calculates, divides. I think it goes from right to left in this case. Though, frankly, I'm not really sure what is the correct order. What I'm curious, however, is why it doesn't see all of the materials. So let me quickly pause it and do basically a small diagnostics. It did work before, so let's see what's not working. Okay, it seems if there's far too many of items, it has some issues. So let's do a small variation on that. Rather than calculating it immediately, I will remove that and move this here. Okay, so what it will do now, instead, is to check how many items we have and compare it to how many we need. So if we have more or the same amount, we will not bother. If we have less, however, then now we will subtract it. B, C, B, and push it here. Now it should correctly clean it up. Right, clean it up. It didn't clean it up, and I know the reason. I think the good idea would be to add additional copy or cleanup, just to make sure it works as intended all the time, rather than almost all the time. Now, even if something is set here, it will clean it up if the current target is fulfilled. Okay, so let's quickly check. I wonder if I could try to put this copy into the grid to see if it's fulfilling the requests. I do wonder, however, checking right now if every item is available. Right, one thing. You might notice that this design is working with assemblers only. If we were to add, for example, robotics option, we will simply replace it with robotics factory. Same with refineries. So instead of having entire grid, we would use 3 specific constructions just to make it clean. We could, of course, instead of using that option, let me quickly save that one as construction support. and save it. Now, we could also remove this division. If we do remove this division, we can remove entire assembler 1 or 2 and simply copy it to 2 different modules. For example, if we were to replace it with robotics facility, we can simply remove the divide by 2, or basically divide it by 1, the same action, and now it will make anything that can be built either in assembler or in robotics assembler. So basically this is mix and match what you need. However, there is that weakness that I may have mentioned, that it is only looking at this area. We can expand it, in fact, and let me show you how. Let us create a small, simple building. We will slap on that, well, let's go with something simple. Portable radar and signal reader. I will quickly drop 2 signal readers, in fact, and radar onto the construction area. And this building is what we can basically daisy chain if we want to create mobile radar stations that expand our site into what we need to build. Actually, let me quickly make a variant that's independent of power grid. So let's grab this one. Then let's grab, well, capacitor, or in this case, small battery, just to make sure we are not gonna run out of energy. Let's grab portable radar and a signal reader. And as I've said, construction own, construction radar extender. This way, if we put it, for example, let's see, and let's make it a bit further from the area that we have, just to show you how it works. As this is the area where our radar already works, so let's put it perhaps here, just to show you how it works. We could, in fact, create a variant in which this radar extender lies within the previous area, just to make sure we are provided with all the materials that we need, but I assume everything is available right now, and if not, well, not a big problem. In fact, let me grab that one. There's a construction site remote option. We can drag it here. And we can remove this one, as this is closer, but it's not going to be built. Our radar will, our site will check our current remote site, and it's ready. In the meantime, let me quickly grab signal reader, just to prepare for extension of the radar network. We have a radar, we have it set up, so only thing we still need is for our construction supplier to connect to that radar. We will use one of those, and we will be able to daisy chain these radars as we need, which is why the design used signal reader. Oops, wrong. It's here. Okay, so let's see what happens if construction site is within range of this radar. So let's put it somewhere here. It should be beyond, yes. So this radar identified there's a construction site. It refers to its signal, and the signal is read by our construction supply. This way we can expand it further, further, and further. If you want to create a network like a tree, in which a single, say, radar congregation of sorts is taking signals from multiple radars, you simply create a small building with multiple signal readers. In this case, there will be 3 of them. Link the input registers to the radar sites that we want to, and simply put all the outputs to the signal. Yeah, 3 to 1. We could also make something more complex and use this construction supply to create an automatic off-grid construction bot. It will work quite similarly, again by reading the signals. And yes, as you can see, the remote signal is targeting the resimulator, but it seems the most important currently needed one is, well, circuit boards. But it's off-grid, so we can fix that quite quickly. Let me quickly create a simple worker bot that's cheap and sufficiently advanced. And in fact, let me add to our program one more copy. Let's go with bot target. Our bot target will be basically a signal that we output from our helper for our construction bot to know where to go. So as we read the signal, we'll basically copy our target to our bot target. However, this way, while clean what is going on, is a bit inefficient, so I'll remove it and put it directly to the signal output. This is going to be basically our bot target. However, I first added it to parameter just to explain how it works. Okay, so we have that one. Sorry, I forgot to relink it. Let me quickly create a worker. To the worker, I will add simply a single behavior control. That's sufficient. Let's quickly wait until the metal bars are there. I'm not sure if it's metal... yes, I see what's wrong. Metal bars were not connected to the logistics grid. I'm not sure if you're using point-to-point transporters here. If not, they were simply not connected to the... Ah, right. Okay, so this one is... give me a second. Yes, it wasn't set to transport route, for example. So let me turn that off now. It seems to work. Anyway, let's quickly relink it as we have the worker up and running. And let's grab the most powerful and most OP item in the game. Excuse me. Okay. So, we know that our... Okay. I'm not sure if this is a program that you want. So just in case, I will copy it as a backup. Anyway, let's clean that up. And let's add, as our only parameter, construction supply center. And we'll grab it here. Okay, now what do we want this behavior to do? We'll call it construction supply bot. First of all, we want to check if we have construction supply center. I will quickly add the unlock just to make it faster, because frankly speaking, if I don't, it's gonna take far longer. Okay, so we have construction supply center. Let's read. Let's first check if it is there. And if yes, we will read the signal from it. A is our construction site. Again, we are checking if first it exists, and if it exists, we are making sure it is in fact a construction site. If it's not, or doesn't exist, we clean it up. Just to avoid situation in which our signal here gets some junk, such as, for example, an item count signal regarding, well, for example, complex signal that I'm using, or basically whatever else that is not a construction site. Sorry, not succeeded if it failed. Okay, so now we are sure, perfectly sure that our A is a construction site. What we're doing next? Well, basically what we did in a construction supply center. First, we read what we need, exactly the same way. However, now we're gonna do a small trick. Well, not trick, small difference. We will now request an item. What item? Well, exactly what we need. And we'll also make sure that if first item, if we have an item, basically, first let's check if we have items in the cargo hold. If we don't have, we can immediately request item. If we do have, however, I'm afraid we have to compare whether we have the correct item. Let me quickly find the correct, yes, that's this one. Okay, so if we have currently in our cargo hold We're currently using a small bot, so worker, so we'll only have one bot. If it's equal, well, basically we request all the rest of items that we need. If it is different, however, I'm afraid we have to drop off the junk we have. Let's drop it off, for example, either to our junkyard. In fact, I will add a junkyard. Now, let me make a small correction, as drop of items may not work as intended all the time. So instead, I will make it order transfer to the junkyard, and we will drop the item that we don't want to. We will make sure we are in range, and once we dropped it off, we are sure that we have nothing else, so we request the item. Next step is, well, to wait a bit. So we will add a wait tick. And now we are basically checking how many items we have. So again, we count items. We know that B is the amount that we want, so we count how many items that we want we have. We are not using here C, so let's grab the C. Just not to use the same thing over and over again. However, to make it clearer, we can also add D. That's your choice. And we compare the number. Again, how many we have, how many we need. If equal or larger, we're gonna go. So if we have enough items, basically, what we want to do is we move to A. I'd like to remind you that A here is our basically construction site target. And again, order transfer to drop that item. There is a problem, however, if the value is smaller. In some cases, it may be that our construction supply bot will not be able to carry all the items that we need. Let's make sure that this is not the case here. So, what we're gonna do is we're going to check space for item. Again, B, D, here in this case both should be available. So, if it can't fit anymore, so basically we're full of that item, we'll basically do the same as if we had enough. But if we can fit more, we basically have to wait until the request is fulfilled. Once we're done here, we go all the way back here and check it again. We check if construction site is ready, we get what we need, all the way up. This way, whatever let me set this one as a junkyard just for clarity. Sorry about that. Okay, so let's use that as a junkyard, start it up and see what it does. I add move and drop off just for both for clarity and to make sure it can order transfer to. I'm not using drop off items, as drop off doesn't exactly work as you'd like always in case of components. Sometimes components do get accepted, sometimes not. This is just a small variable or insanity of this version. On the other hand, move unit and order transfer to doesn't transfer it immediately. If you're next to it, however, it will transfer as needed. Now, let's see. We have basically no construction site right now in the range. so our worker or construction supply bot will do nothing. Let's start by making a small, perhaps circuit board, because it's mostly cheap. And let's see. It needs 4 circuit boards to make. It requested 4 circuit boards, waited for them, and is going to the construction site. It is now out of the grid. It dropped it. It's waiting a bit. And we forgot to add one more thing. Once it checks and delivers the items, it ordered a transfer, we should check right now if any more of those items are needed. Let me quickly check it. Let's quickly re-request signal, just to make sure we have exactly what we need. Okay, now let's add one more thing. Whenever our bot is waiting for another piece of information, another item basically, we want to make sure it moves to our construction site, construction command, just to make sure it's working as intended. That way it should first grab a set, and when in doubt, it will return back home. And it's going where exactly now? Ah, right, it's full. We can of course add power supply here, just to make sure it doesn't run out of energy. As you could see, it now requires only 10 pieces, not 20, not full stack, so it adapted it. Gets filled. Now, as it's returning back home, just in case, well, it first will go home. We can replace the move with move async or asynchronous. In the case of whenever there is in fact fulfillment of that request, it will basically start moving in different way. Now, it fulfilled the request, it's moving home, and let's swap these two in places, just to make sure it won't make items, I want to grab items that we don't want. So this is basic option. We could in fact add cleanup of the resources just in case, and so on. But it should be simple enough for basic utility and creation of off-grid factories. Let me quickly remove it and let's clean it up. I'm pretty sure there's no need to have wasted resources on items that we don't need at the time. So yes, while the drop-off should include move, it's just to make it clean and more robust. Do you have any questions? Perhaps if yes, I'll gladly answer them. Now, for the record, it's not the most optimal option, it's not most robust option. We could work on adding a few more checks just to make everything clear, but it should work sufficiently well. a relatively simple option. Now, one more fun fact, if you're interested. This worker has an interesting option when it comes to this code. If you remove the first check, and if you basically swap read signal with copy, in fact, let me save it and create a copy of that one. Let's expand it a bit. There is a quite fun fact regarding workers and radars when it comes to construction and exploration. They're almost the same. What do I mean by that? Let me grab a worker, grab a behavior, well, you could use more advanced bots such as, for example, Scout for that, but just to highlight how extremely close this and exploration system are, I'll grab also a radar. In the meantime, I will copy what we had. Slap on the radar. And create the filter unsolved. And as this is a demo, let's limit it to bots. Okay, now we'll replace that with exploration site. Stay with junkyard. Link the junkyard and link this one. And finally, we're not going to be checking if we have construction site. We will in fact read it immediately. Oops. Yeah, I'm afraid that is a small problem with complex behaviors. Let me quickly unlock it and then remove what we don't want. Just to make it clearer what's happening here. It's basically saving the exploration site and is doing exactly the same thing here. Let's quickly find an explored robot within radar range. Perhaps up. Nope. There's a plateau here. We're basically looking right now for anything that we can use to explore. Power plant, that's not. Well, we could also add a power storage, and I think I should add that one. Just to make sure we don't run out of power too quickly. Actually, I think we found one. So, we found the explorable. Hold it, hold it, hold it, hold it. Now, one thing we have to keep in mind, however, right now, I will try to cancel it, so give me a second, as it's ordering wrong delivery, in fact. What we have to change here is that we cannot drop the item. Unfortunately, when it comes to explorables, automatic transfer of items will not work well. It will basically not be registered that it just did so. So instead, rather than dropping it, we will add notification that we're done and a ping. And we'll wait. And check if the item we're pinging is in fact unsolved. If yes, we'll annoy the player. If not, oh well, we'll basically wait and start from get-go. So after this small fix, let me quickly pick it up. We can see that it pings what it needs. And as you could have seen, unfortunately we couldn't drop it automatically, we had to pick it up, and now we click it manually. Now let's verify if it works. So let me quickly drop that, just to verify. Let's start it up. Okay. Right, one more thing. Our old system was moving to our basically construction site. Here it's trying to go to exploration site. Let's move to headquarters instead. We'll grab the location of headquarters and go to headquarters instead. This way it will wait for the resource that we need, nice, tidy, next to our headquarters. And here we go. We'll quickly check if every other piece or existence where we move to explorable, except for the final one, goes where we want. So let me quickly check during the request. Let's move the, let's do a small change then. What I will do now is basically reconnect home all the way here. As basically whenever we need to go home, we'll go to E instead. Request item, we need to move home, then read and check everything else. Okay. Now should work better. Unfortunately, as this is not designed to ignore or skip the explorable, I've got to drop it and restart it. If there are any bugs, and most likely there are small bugs, I'll have to basically debug it. Anyway, it goes explorable, drops it, says it's ready to transfer. We need to pick it up later on. For example, with a scout. And our worker, in this case, can look for further unexplored or rather unsolved structures. Now, broken miner. Why your visual register is controlling how much it requests? Basically, it doesn't. What it does here is that our radar is grabbing the resource crystal. It, in theory, orders exactly the amount that is left here as the amount that we want. So let's relink it. If we want to make sure, yes, radar is ordering the target, so basically this chunk, and it's checking how many items are there. In this case, 3 of them are left. So what it is doing is it is ordering the miner to have in cargo 3 units of crystal chunks. And as there are 3 units of crystal chunks in cargo, well, it stopped mining. If there was 1 unit left, it would do just the same. However, it would mine until it has 1 unit in cargo. Instead of this variant, I would recommend using either baseline. If there's 0, it will basically mine as long as it needs. Or the other way around, use visual register, set to infinite, so that we can see how many of crystal chunks we have in cargo, and move that to our RAID miner instead. And radar, really. This way it won't really bother with checking how many of these items are. And if you want our miner to get as close as possible to the nearest radar chunk, we could link it here, like that. However, if I may be so honest, I do not recommend it. Why? When there's multiple bots nearby, they will clutter around a single crystal piece. The problem here is that if they clutter around one piece, suddenly not every miner will mine it at the same time, because it won't be able to get there. On the other hand, if we have, for example, infinite amount pushed directly to the miner, that mining tool will look for nearest area by itself, for nearest accessible crystal chunk by itself, in this case. This is a quite similar problem to what would happen if we were to, in fact, link this to, for example, keep at range command, because keep at range command would basically order it to go no closer than, in this case, 50 blocks, which would be counterproductive, really. Now, why is the visual linked here? We could, in fact, also, give me a second, sorry, I will blabber a bit. We could, in fact, here set it to infinite, and it would work just as well. But why I recommend using visual register or any other register is that once we order it to move, the register and mining tool gets cleaned up. That way, we can use visual register, relink it, and in this way, if we want to use radar to go closer, let's go with this setup, and it will basically look for any crystal chunks within the range that we can see now.